You ever have one of those brilliant app ideas, but you have absolutely no clue if it's a week's worth of work or a year-long epic? That is the fundamental challenge in software. How do you measure something that doesn't even exist yet? Well, today we're going to build a framework to do exactly that.
I mean, think about it. It's a classic problem, right? You're essentially trying to measure a ghost. Is your idea a tiny little rowboat, or is it a massive cargo ship? If you don't have a reliable yardstick, you're just guessing. And let's be honest, guessing is a terrible project plan. So let's build that yardstick. For a long time, the go-to metric was lines of code. But that's just a terrible idea. It's like trying to price a house by counting the number of nails used to build it. It tells you nothing about its size, its features, or its value. So we need something smarter, something focused on the user. And that's where function points come in. See, they don't care how you build it. They measure what the software actually does for the person using it. And that's what really matters.
So how does this actually work? Well, the real magic of function point analysis is that it can take any piece of software, I don't care how complicated, and boil it down to just 5 basic types of interactions. Think of them as the touch points. You know, the places where the user and the system actually meet. Okay, let's just quickly walk through these 5. First up, you've got external inputs, or EI. That's any data the user sends into the system, like filling out a login form. Then there are external outputs, or EO. That's when the system sends processed data back out, like generating a sales report. External inquiries, EQ, are simple lookups, a user asking for info without changing anything, like a product search. And finally, we have the data files. Internal logical files, ILFs, are groups of data the system manages itself, like your list of customers. And external interface files, EIFs, are data the system uses but doesn't own, like connecting to an external payment gateway. That's it. That's the whole shebang.
All right, so theory's great and all, but let's make this real. We're going to apply this to an example we all know and probably use, an online food delivery app. You know, something like a Swiggy or Zomato. We're going to estimate its size from the ground up, just using these 5 components.
So the first step is to just break the app down into its core features and count. Let's take order placement, for example. That's probably 2 inputs from the user, 1 output to confirm the order, 1 internal file to store the order, and 1 external file to talk to the payment system. You see? We just go through every single feature like this, counting and tallying them all up to get our grand totals for each of the 5 types.
Okay, so we've got our counts. But we all know that not all functions are created equal, right? A simple search is way less work than a complex financial report. So the next step is to assign a complexity weight, low, average, or high, to each of our counts. Then you just multiply the counts by their weights, add it all together, and that gives us our very first real number, the unadjusted function points, or UFP. And for our food delivery app, after doing all that math, we land 208 unadjusted functional points. Now you should think of this as the raw functional size of the app. It's based purely on what it does for the user before we start thinking about any of the technical stuff under the hood.
But here's where it gets really interesting, and this is a crucial point. A simple internal to-do list app and a high-security banking app could have the exact same number of functions, but we instinctively know the banking app is a million times more complex to build. It has to be fast, secure, always online. This is where we need to apply a reality check to our raw number.
This reality check has a name, the Value Adjustment Factor, or VAF. And how it works is, we rate the project on 14 different general system characteristics. For our food app, things like real-time data communication, high performance, and complex back-end processing are absolutely critical, so we're going to rate them high. This process is how we capture all those non-functional requirements that create a ton of extra work. We take the total score from all those 14 ratings, and we plug it into this simple formula. Don't worry too much about the numbers themselves. What this formula does is create a multiplier, and that number, the VAF, tells us exactly how much more or less complex our project is compared to an average one.
For our food app, the total rating from those 14 factors adds up to 48. We plug that into the formula, and we get a VAF of 1.13. So what does that mean? It means our project is about 13% more complex than a standard application of the same functional size. And, you know, for a real-time delivery service, that feels about right.
The final step to get the true size of our project is incredibly simple. We just take our initial raw size, that unadjusted function point number, and multiply it by our reality check score, the VAF.
So, 208 times 1.13 gives us 235 adjusted function points. And this is our final number.
This isn't just a measure of features anymore. This number represents the true, complexity-adjusted size of our project. This is the number we can actually work with.
Okay, so we have the size 235 function points. This is huge. This number is the common language that gets the business folks and the tech folks on the same page. But what does 235 actually mean in the real world? Well, now we can translate that size into things that everyone understands: effort, cost, and time.
To talk about effort, we need a standard unit. And in software, that unit is the person month. It's exactly what it sounds like, the amount of work one person can get done in 1 month. So a 4-person month project could be 1 person working for 4 months, or it could be 4 people working for 1 month. It's a measure of the total volume of work.
So how do we get from size to effort? We use something called a productivity rate. Think of this like your team's average speed. It's a benchmark for how many function points your team can typically build in a single month. So if we divide our total adjusted function points by this rate, we get the total effort required in person months.
Let's say for a typical web app team like ours, a productivity rate of 10 function points per month is a pretty good historical average. So for our project, we take our 235 function points, divide by 10, and that gives us a total effort of 23.5 person months. That's the total amount of work needed to get this done.
And once you have the effort, figuring out the cost is actually the easy part. Let's assume a fully loaded cost, that's salary, benefits, office space, the whole deal, of about 1 lakh rupees per person per month. Well, 23.5 person months times 1 lakh, and the total estimated project cost is 23.5 lakh rupees. Just like that. We went from a list of user features directly to a data-driven budget. Pretty cool, right?
So we have the size and we have the total effort, but hold on. 23.5 person months does not mean the project will take 23.5 months to finish. That's a common mistake. The final piece of this puzzle is the actual timeline, the schedule. And to figure that out, we need to bring in one more idea.
And this is where a different estimation model, like Kokomo, comes into play. Now, it might seem like we're just adding more complexity, but they actually work together perfectly. Think of it this way. Function points tell us what we're building and how big it is. Kokomo helps us figure out how we're going to build it and how long that will take with a specific team.
Here's the simplest way to remember when to use which. You use function points when you're talking to the client. It's all about the what, the features, the scope. It's perfect for setting a fixed price. You use Kokomo when you're planning with your development team. It's about the how. It factors in your team's skill level, the tools you're using, and most importantly, it's what you use to calculate the actual project schedule.
You know, all these tools, all these models, they really just serve one purpose: to give you clarity before you start spending a ton of time and money. There's that old saying, and it's so true here: the best time to properly plan your project was at the very beginning, but the second best time is right now, before you write that first line of code.
So there you have it. We went from a simple idea all the way to a concrete size, a real effort estimate, and a data-driven cost. You now have a framework to do the exact same thing. So I'll just leave you with this question. That big idea you've been kicking around, is it a 100-point sprint or a 1,000-point marathon? Now you actually have the tools to find out. Thanks for tuning in.